Well, good morning, everyone. I'm Erin Silva. I'm an assistant professor at the University of Wisconsin-Madison and also the state extension specialist in organic agriculture. So my program is very broad across organic systems here in the state. Wisconsin has the second highest number of organic farms out of any other state in the country, only behind California. So we have a very vibrant organic industry here, and an organic industry that represents really the range of organic products. So we have vegetable farmers and row crop farmers and dairy farmers and other livestock farmers. So my program really looks at needs addressing all of those different market segments of organic and all those different production approaches. As compared to, I think, one of the other versions of the agenda, I will be speaking rather than Eric Beidela, who was a graduate student, is a graduate student that had this work as a component of his master's thesis. And Rachel Weil, who works in my program, is going to be talking about labor needs, which I was originally on the agenda for. So a slight adjustment from what was originally posted, but I think it's correct in this latest version. But I will be talking to you about implementing cover crop-based reduced tillage in small-scale organic vegetable production. And this is an effort of a couple graduate students of mine, Ann Pfeiffer and Eric Beidela, and also a weed scientist in the Department of Horticulture, Jed Cahoon. All right, so in all types of organic approaches, all types of the organic market chain, I guess, weed management remains a primary challenge. As Rachel will talk about in her presentation, much of the cost of production for organic vegetable crops is tied up with labor. And a significant portion of that labor is then tied up in weed management. Organic producers really rely on cultural management, either through crop rotation, through the use of cover crops, through the use of mechanical tillage, or through the use of hand labor to manage weeds in their system. So organic producers are continually looking at how to optimize weed management strategies and innovating and identifying new strategies to effectively manage weeds while retaining and even building soil quality. As Anna had mentioned in her presentation, the reliance on tillage has detrimental effects to the organic system. It can cause loss of soil carbon, it can have negative impacts with respect to soil physical properties, and it also can leave the soil surface bare for being susceptible to erosion. So if we can look at ways to minimize tillage, keep the soil covered, and to help with weed management of the organic system, we're really looking at winning in multiple ways. So we've been doing a lot of work here in Wisconsin with teams of researchers across the country on a method that was really started in South America. It was picked up by the Rodale Institute and really promoted by the Rodale Institute quite heavily. And it's looking at a cover crop-based reduced tillage system. And this system is using cover crops that are planted at some point within the growing system prior to the cash crop planting, and using that as essentially a killed mulch to suppress weeds. So using this system, we've had quite a lot of successes here in Wisconsin and in several other regions of the country on implementing these practices using roller crimpers, using field scale equipment and agronomic systems to suppress weeds and to manage the system while reducing tillage and even eliminating tillage for certain phases of the system. The rye soybean system stands out as a particular success story using this method. There's been success using hairy vetch and corn. But what we're looking at and where there's interest from Wisconsin vegetable farmers is, can we use these same techniques and the same types of applications for organic vegetable production here in the state? So the hypothesis of our research was that cover crop-based reduced tillage techniques will suppress weeds and reduce the amount of time required for weed management by vegetable growers within the production season. And one of the primary goals of this research was to identify best cover crops and best cash crops that may be best adapted for this system. So to do this, we planted several fall seeded cover crops. So these were planted sometime in September. These were broadcast seeded by hands. Because of the original funding source for this study and because of the scale of vegetable production that we tend to see here in Wisconsin from organic producers, we did try to stay at a small scale. So we broadcast seeded by hand, and this definitely could be scaled up, but we were really focusing on smaller producers that might be more reliant on hand labor. The rates that we used were 3 bushels an acre for winter wheat, 3 bushels an acre for winter rye, and then we tried to mix 40 pounds per acre of hairy vetch, the variety being Purple Prosperity, which is a variety that is known to bloom 2 to 3 weeks earlier than a typical hairy vetch variety, which tends not to bloom until middle of June, end of June here in Wisconsin. So this would bloom more in a end of May time frame. And then a rye vetch mix, 3 bushels an acre of rye and 40 pounds per acre of vetch. Unfortunately, the Purple Prosperity is also known for not having as good of a winter hardiness as some of the other varieties of vetch, or the vetch, a seed that's available on the market as a variety not specified, which is why we bumped up the seeding rate considerably, hoping that we would be able to at least have some survival through the winter. We did 4 replications in a randomized complete block design, and each of the treatment plots were 15 by 20 feet in dimension. We rolled and crimped or mowed these ad anthesis the following spring, and then we planted the cover crops into the residue. So what we primarily used then was this VCS sickle bar mower for the mowing of the crops. This was something, again, that a smaller scale grower could be able to have access to and be able to manage these operations by hand. Prior to mowing, though, we did, before the rye got too high, we did strip till 9-inch rows at 30-inch spacing, and we did this continually through the spring to manage the rye residue and to keep the rye regrowth down. If we had waited till the rye was at the stage that we needed to successfully terminate it at mowing, it would have been too difficult to manage, and we did want to try a strip till technique, again emphasizing the fact that we were doing this by hand and we didn't have transplant equipment that would be able to penetrate through that mulch. The crops were then seeded and transplanted into these strip tills after we mowed the cover crops. We used a 15-inch in-row spacing for peppers, a 3-inch in-row spacing for snap beans, and a 12-inch spacing for potatoes, the 3 crops that we chose to evaluate using this sort of technique. We applied pelleted chicken manure once after planting as a side dress, not only to snap beans but to bell peppers and potatoes, and then we irrigated with drip tape. So here's some photographs of those treatments. Now this was after mowing, obviously after these crops were planted, but just to give you an idea of what this looked like. Our winter wheat, our cereal rye, and the mixed rye vetch plots. Unfortunately, like I had mentioned, it is known that Purple Prosperity vetch does not have good winter hardiness. I think Albert Lee Seed Company, which is one of the primary sources of cover crop seeds for organic growers here in the upper Midwest, has even stopped carrying this variety because it is so risky here in the upper Midwest. So we did not get good survival of the vetch. So essentially these mixed plots were rye dominant, essentially completely rye versus having any vetch included within them. We did use an oat straw mulch then on the plots that we had only vetch and there wasn't enough residue to suppress the weeds. Instead we then fell back on a treatment where we used oat straw mulch. Unfortunately, you can see here in 2014, this past summer, there was a lot of oat seed included in that oat straw mulch. So you see a lot of oats coming up through that. And then we had a brown control as well as a treatment. And here you can see one of the reasons why we want to adopt this technique. You can see after some of our more extreme weather events that we've had quite commonly here in Wisconsin over the past several springs that the ground is very prone to erosion without that cover on the soil surface. Like I mentioned with the materials and methods, the 3 vegetable crops that we chose to integrate into this experiment were green bell peppers. We chose the variety Revolution. We chose snap beans, the variety Tavera, and then red Lesota potatoes. The data that we collected included initial cover crop density and biomass, Then we took weed density and biomass measurements 5 times throughout the growing season. We also measured weed management time, so the labor savings that these techniques might provide to growers 3 times during the growing season, and the yield and quality of the produce. So even though we were hoping that the mulch would effectively limit weed seed germination and manage the weeds primarily in the system, because we were adopting a strip till technique, there was some weeding that needed to be done as the cash crops established within the rows, so that's where the weed management time was primarily targeted to. So here's some data that we collected over the 2 seasons that we conducted these experiments, 2013 and 2014. At anthesis, measuring cover crop density, so we were terminating, because the vetch did not survive, we were focusing our termination strategies and our termination dates on anthesis, when the small grain crops were starting to shed pollen, and at that stage, physiologically, the plant is triggered to terminate when we do use some sort of practice like mowing or roller crimping. So it's really essential for a grower to wait to this stage. Again, here in Wisconsin, that tends to fall around Memorial Day. So with respect to adopting this within a vegetable crop system, it can be very well integrated into a warm season vegetable planting. That's typically the time our producers are putting out peppers or planting some of their beans in the bean rotation, tomatoes, etc. So this is again then that time period around probably the 3rd week of May when this data was taken. The rye, again the mixed data, the mixed treatment is essentially entirely rye, and then the wheat. In 2013 there was a slight overall advantage to winter wheat with respect to the mean, but there really weren't any significant differences between any of the treatments in either years. And the sorts of biomass that we were getting measured here on the smaller plots, about 1,000 grams per meter squared in 2013 and around 800 grams per meter squared in 2014. If you translate this into a kilogram per hectare basis, basically adding a 0 to those numbers, so it would be the equivalent to 10,000 kilograms per hectare or 8,000 kilograms per hectare. These are in the target range where we typically look at an agronomic system. So the biomass was actually quite good in both these years. When we then took weed density and time required for weed management, though, we were a bit discouraged with the results. Weed density in this first weeding, so this is typically the time where we would expect to see a lot of weeds in the system before the cash crop started to set a canopy, and when that initial flush of weeds starts to germinate and establish, we saw that the control plots did have more weeds than the cover crop treatments. However, we found that it did not benefit the growers with respect to weeding times. Trying to weed around that mulch or even pull some of the larger weeds within that mulch was more time consuming for weed management than going through with different cultivation tools that we had available, as well as hand weeding. So it was pretty laborious for our student employees to go through and try to manage those weeds within the row in the mulch plots. We did not get significant benefits with respect to weed management time. In our second weeding, we did not see significant differences again between weed density, and again our weeding time was not significantly different either. So we weren't seeing significant benefits by having those killed mulch systems within the vegetable crops. In 2014, we saw a similar story. The weed density early in the season was not significantly decreased with the rye and the wheat cover crops as compared to the control. We did see significant management. We applied that straw as an additional treatment, however. And similarly with the weeding times, because it was it took a bit more effort for the students to strategically weed around the mulch and be able to still weed within those rows. It did not save time with respect to weed management by having those killed mulch cover crops. And again, similar story with the later season data as well. And these were just 2 data points out of the suite of data that we collected. So what are we seeing then with respect to yields? We did see variation with yields depending on which crop that we were looking at. There were not significant differences between the control plots and the rye and the straw plots. We did see a bit of a yield reduction in the wheat plot with respect to pepper yields in 2013, and in 2014 we actually saw a reduction in yield on the straw plots, which was a bit surprising, but not significant differences between the rye, the mixed and the control plots. So the systems did not have a detrimental impact on yield, although from the previous slides data we did not see a significant impact on weed management or labor times. For our bean yields, here there was more of a detrimental impact with respect to yield. Our control plots yielded more beans than any of the cover crop plots. And in 2014, we did not see a significant difference between the control and the rye, but overall we saw some of those same trends where the control plots were yielding more beans than the cover crop treated plots. And with potato yields, in 2013 we did not see any significant reduction in yields or any significant yield advantage in the control versus the cover crop plots, and in 2014 we did see significantly higher yields in the control plots versus any of the treatments. So from these 2 years worth of data that we collected, some conclusions. The cover crop based reduced till plots did not significantly reduce weed biomass or labor time as compared to the control. So at least within this site, with the suite of cover crops that we chose, we did not find those weed suppression characteristics that we were hoping to see. The impacts on yields varied by treatment, year, and crop. So there did appear to be some crops that may be more adapted to this system, and I think that there's a variety of reasons why that might be. Some future research. We want to try to see if we can better identify optimal cover crop and vegetable crop varieties that may work more consistently with this system. As we look at different vegetable crops that may be more adapted for this sort of technique, I think one of the key aspects that we need to look at are crops that might be able to close canopy and be more competitive against weeds by layering on, I guess, other management techniques. One of the reasons why the soybean system works so well is that the soybean, where the rye is really benefiting the system, is more of that early season weed management. Eventually, though, weeds tend to break through that system, and we further suppress the weeds as the cash crop starts growing through that canopy closure. And I think with granted, the soybeans are a longer season crop, but I think that ideally to have this system work consistently, we need to choose vegetable crops that we may see some of those similar characteristics. So the peppers that may grow into bigger plants that might close a canopy to further shade the weeds as the mulch starts to break down through the growing season. If we could maybe optimize row spacing, that we don't have detrimental impacts on yield or nutrient availability or water availability. But again, if we're really looking at trying to make the system work consistently, trying to layer on multiple weed management approaches so that we're not relying entirely on the mulch. Or if there's cover crop varieties that are more adapted to the system that can reliably produce enough biomass that we're going to have good weed suppression, particularly early on, but even throughout the cash crop production season. Identifying optimal cover crop seeding rates. It does appear that even though from the biomass measurements that we obtained early in the season that the mulch was not thick enough to reliably suppress weeds throughout the growing season. So perhaps we could bump up our seeding rates to try to accommodate this and produce more biomass to allow for better suppression, or perhaps we could try different cover crop mixes that might allow for different advantages of the various cover crops with respect to building a thick enough mulch that would allow for good weed suppression. And then developing effective equipment is really key. Even though we were looking at smaller scale production, hand scale production, there is interest in developing these sorts of techniques for larger scale vegetable producers as well. And so this is a photograph of the sorts of equipment that we use for our soybean no-till plots, the plots that we do crimp the rye that had been seeded the previous fall. The rye then grows through the spring. We crimp it when it's at anthesis about 5.5 feet tall, and then we are able to drill the soybeans directly into this mulch. So here we're using field scale equipment, heavy equipment that is very effective not only in terminating the mulch, but also allows us to get the soybean planted through that mulch and into the soil for good seed to soil contact. And part of that is having equipment that's heavy enough to be able to do those sorts of operations. However, we don't necessarily have those same sorts of equipment adapted for vegetable crops. Rodale, who designs the chevron-shaped roller crimper that I just showed on the previous slide, has also looked at developing specialized equipment for vegetable crops. Here's obviously this roller crimper is much smaller in width. It actually has various heights so that there's one portion, the center portion of that roller crimper is going over a raised bed, while those two lower wings are actually crimping the cover crop in the alleyways. So there's efforts into designing better equipment for vegetable producers. This was something that I found as I was getting ready for this presentation. We had talked about how we used a sickle bar mower on a BCS mounted, or a sickle bar mower on a BCS tiller. This is actually available for growers. It's a manual, 30-inch manual crimper roller that can be attached to a BCS implement. So these sorts of things are being designed, and they are available for vegetable producers. This was actually one that I found on a website. I did have the website on the bottom of the presentation. I'm not sure where it went, but this was one that a farmer designed himself. Again, it's being propelled by a rototiller, actually, in this case, but he's standing in front of a little roller implement that he fabricated, rolling down some mulch. But the comment that I found on this website was, unfortunately, managing the cover crop timing and coverage in the aisle proved too tricky so far. So mirroring some of the experience that we had, that really getting good coverage in the alleyways where you're trying to manage those weeds is difficult. And if you aren't able to do that consistently, you can actually make weed management more problematic instead of allowing a farmer to derive benefits from this system. And planting equipment as well. So like I mentioned, with the larger scale field operations, we're able to have heavy enough equipment, no-till drills that allow for the soybean seed to penetrate through the mulch and get good to seed soil contact, and that crop is able to establish. We don't necessarily have as much access to that sort of equipment that might be adapted to a no-till cover crop-based system in vegetables, but there are some sort of different types of equipment that are being designed. For instance, here's being planted through a mulch, dropping transplants in through a slit that's being cut through that mulch, but these aren't necessarily readily available to vegetable producers. Let me go back a slide. So I just want to thank again the graduate students that adopted this project as part of their master's theses, and Pfeiffer and Eric Beidela, and our funders, the USDA Sustainable Ag Research and Education funding, Ceres Trust helped fund this project, and also USDA AFRI grant, particularly that community and regional food security project. And I can take any questions.
Questions for Erin?
Yeah, one of the things with growing peppers is I don't mulch them because they want a warm soil temperature. Yeah. And so I'm just wondering, were you monitoring soil temperature with the peppers? And yeah, how do you think this system can work, or what modifications need to be made to help increase that soil temperature for peppers?
Yeah, the soil, we did do the strips, 9-inch strip till, so there was some bare soil right at the base of the peppers. Getting the planting date that we were shooting for on this, which is more of a late May, early June planting date, I don't think, it tends to warm up enough in southern Wisconsin that I don't think that we would be suffering from the same decreases in soil temperature as trying to get into a earlier planting date, where those black mulches and warming the soil might be more, have a greater impact. So I think between the fact that we're having a, again, that strip till as the crop is establishing, and then by the time the canopy's covered, it's later in the season to the point where our air temperatures are not, they're pretty high in southern Wisconsin anyway. So we didn't see any potential impact of that on our trials, and I wouldn't think that would be a significant concern with integrating peppers in this system.
Okay, thank you again.